can start, since there's so few of us, start with introduction. So I'm Seth Rubin. I'm a professor in chemistry and biochemistry, and I'm the undergraduate faculty undergraduate advisor, and organized this.
Yeah, so here's my face.
Sorry.
Yeah, that one. So my name is Michael Stone. I'm also a professor here in the Department of Chemistry and Biochemistry. I'm the current director of our graduate programs, both the master's and Ph.D. programs here at UCSC, both chemistry and the umbrella program that we call the program of biomedical sciences and engineering. So yeah, so I'm here and excited to talk to you guys and answer any questions.
Then we have a panel of graduate students, recently graduated undergrad.
Yeah, I'm Brendan Chrysler. I'm a fourth year graduate student at Johnstone Lab. Yeah, we're a bioengineering lab.
My name's Alfred. This is my face, what it looks like. Just showing everyone I have one. I am currently a lab tech in the Parch Lab. I also worked as an undergrad in the Parch Lab, studying circadian rhythms using in vitro biochemistry.
I'm Sam. I'm in fourth year, and I'm actually in the Rubin lab, studying metabolism structure.
And so Alfred and Sam have gone through the application process this year. Why they're here. And Marla, do you want to introduce yourself? Did you already introduce yourself?
Hi, I kind of said hi to all of you already, but I'm Marla. I'm the chemistry undergrad advisor. At some point, Rex didn't be the advisor if he has get out of his meeting at the right time. Hopefully, probably set it in here too. Nice to see you all.
So the plan is Michael will spend a few minutes motivating what graduate school is and why to go. I'll then take over and spend 5 minutes or so, 10 minutes or so talking about the process, what the application process looks like. And then these guys will tell you their experiences. Actually, maybe we should just introduce you. Yeah, sorry.
Maybe you can introduce yourselves, just name and major.
I'm Izzy, and I'm a BMB major.
I'm Manny, and I'm taking a chem major.
I'm Lakota, and I'm a chemistry major.
I'm a chemistry major.
Great. And what year are you guys?
Junior.
Junior.
All
Junior. That makes sense. It'll be the time you'd be interested in grad school. Right, so your slide is
That's good. Yeah. So obviously to motivate why grad school could go in a lot of different directions. So I just threw together a slide showing.
You went one faster.
There we go. So what is graduate school? You know, I think you guys probably have an idea of the answer to that question, and answer that in a number of ways. Let's start graphically answering that. So this is a cartoon that I mapped from the ACS publication, actually, and engineering, the making of a PhD chemist, that applies more generally to PhD training. And so you have somebody sort of warming up, stretching, not entirely wearing proper personal protective equipment, but that's okay. And then this is a timeline, right? Graphical timeline. Sort of first year, sort of uphill, explosive experience. Lots of different things going on. A lot of moving parts in the first year of graduate school, and then you sort of settle in, and there's sort of ups and downs. I think those of us who have gone through it and are experiencing it, and no grad students would appreciate that as certainly a generality that is true. And then sort of year 2, 3, 4, 5, and then sort of at the end, you have like these final hurdles to overcome, right? And then you sort of zip through it, usually around year 5 or 6. So I guess the take-home graphic there is that grad school is non-linear. Right? Maybe is one way to take away the message from that. And certainly we can make generalizations based on sort of collective experience in grad school, but I think the reality is that the experience is unique to the individual, and that's something to keep in mind. as you embark on whatever journey you're thinking about. Interesting. So I just put a couple of text bullet points real quick. Master's degree, types of grad programs. Again, you guys are probably familiar with some of this, but I didn't want to assume anything. And so there's sort of master's degree, and this is really focused on STEM fields, given the group here, which are typically 1 to 2 year programs. They can be coursework focused or research-based focused, or a combination therein. And for many people, that's a great track, and depending on one's career objectives and so forth, a lot of people can get a lot of mileage out of a master's degree. And then there's the Ph.D. or the doctorate of philosophy degree, which is, at least in the US, is about a 5-year, give or take, 5 or 6 year time commitment. I say that because in other international contexts, it's often shorter. So in Europe, for example, the PhD time trajectory is considerably shorter on average. It's typically around 3 to 4 years. In US institutions, the 5-year normative time is sort of what one should be thinking about in terms of the level and scale of time commitment and life commitment that we're making when embarking on a PhD program pathway. There are, of course, many, this is a non-comprehensive list, but there are many fields that one can study for both masters. I'll focus primarily on PhD, just by show of hands. So you guys are here, so you're probably interested in graduate school. Are you thinking, just by show of hands, anyone taking masters? So then, yeah, maybe masters, yeah. And then I guess PhD, yeah, right, so we have a mixture, good. And so, depending on the institution, you can find programs, a master's level degree or PhD in a wide variety of disciplines. Of course, the master's programs tend to be more specific to a specific discipline, generally, whereas PhD programs, particularly in STEM fields nowadays, are becoming more and more multidisciplinary. So that's something to think about when we're looking at programs. Regarding money, which is a very important sort of thing to be aware of, most STEM PhD programs, and this is often not something that undergraduate students are aware of, so you may be, but many are not. The STEM fields tend to cover tuition fees and a stipend that hopefully in principle covers living expenses, of course, depending on where you are, how far that goes in terms of covering it. But the intention is that you're receiving money as a PhD student so that you can focus on your studies. A lot of students don't know that, so I just wanted to point that out. Master's programs are different typically. They're typically paid, or sometimes there's opportunities to supplement the required payment by things like THAs and so forth. Master's program, we can do that sometimes if the THAs are available. But generally, master's programs are paid, and PhD programs you get paid. And so that's kind of an important point. And then this will really vary depending on the program that one, and this is something that you would want to really look into depending on your interests, is like, how is the first or second year of a given program spent, or in a master's program, what specifically am I going to be doing, right? Because programs are really unique when you compare them to one another. And so you're going to want to find one that suits your interests and objectives, right? So if you're interested in being at the bench and doing lab work for a master's degree, for example, you're definitely going to want to find a program that is more sort of research intensive. And those are typically details that you can find on the pages. If we think about research masters and certainly PhD dissertation research, the majority of time spent in graduate school is essentially focused on designing, conducting, and ultimately publishing contributions to a particular field of study. Okay, so essentially graduate students and sort of are at the heart of the engine of research and discovery, sort of pushing the field forward, wherever that research field may be. So they're a critical part of the sort of research apparatus if you think of it on sort of really large scale. And then, right, like the ultimate goal, right? So I'm a big proponent for when you're thinking about grad school, everyone is different. So I don't sort of impose my own thinking on others, but just as a food for thought, they're so, I would say, quite different than when Seth and I were in graduate school, which is like a long time ago now. The landscape of career options coming out of, say, a PhD program when we were going to grad school, it was much narrower than it is now. So, which is a good thing for you, right? So the students coming in now have a really broad array of interests. Some are interested in the sort of what you might consider the traditional academic track. Most are not, which is just fine. I think many are interested in the private sector, whether that be biotech, startup sort of thing, and pharma. Some go along to consulting. I haven't listed everything, but some go to law school, for patent law. Like there's all sorts of different things that grad school can set you up for. Teaching is, of course, a critical career. And more of our students are interested in careers in education and teaching. And so I think the key point is that you want to have this balance, and I'll conclude on this point to just move on. You want to really try to strike a balance at your stage when we're just starting to think about what the path may look like between having a focus and an objective, but understanding that you're going to be molded by the experience and allowing yourself to also search through that process. So that's it. So is there anything else I should touch on that I missed?
My only thought is just, especially because two people raised their hands, potentially being interested in masters, we could somehow discuss more like motivations for one versus the other.
Yeah, so
here's why you guys raised your hand for masters and
yeah, so I can, yeah, I don't know, I don't want to put anyone on the spot. So I would say that there's lots of different reasons that I've encountered in my role as both scientist, mentoring directly students, but also more broadly my role as a graduate director, interacting with 100 grad students at any point in time, as to why somebody might be interested in a master's versus a PhD training. Some students are not necessarily sure that PhD research is like that 5-year, 6-year number is sort of a daunting number, and they're not ready for that. And so some students see a master's potentially as a stepping stone. So we get quite a large number of, like a non-insignificant number of our applicants to our PhD program are people who have already done a master's somewhere. And that doesn't necessarily accelerate their time in our PhD program, but those students often are very solid in sort of their experience and their intention in grad school. So that can be one reason for a master's versus the PhD is like the level of time commitment for an individual's prepared. The other thing is that depending on the career objective, the master's degree, and again, this is very context dependent, so I'm always hesitant to generalize too much, but we've done a little bit of surveying in the private sector to sort of understand what is the value of a master's degree out there in the real world, in biotech, big pharma. And there are jobs, scientist jobs at, all kinds of companies that a master's degree is a really good degree to have to qualify for those positions. Usually those would not be the type of positions that are like group leader type positions, but rather you might be a team member working under a PhD on the scientist. So in the startup realm, that's a little different, I would say, because frankly, if you're good at what you do, when you get your foot in the door, usually there's lots of room for growth, because the bottom line of the startup world is like getting stuff done fast and well, right? And so the degree, I think, becomes a little less important in that context, from at least anecdotally my experience talking to people. So, and then we have, right, so at UCSC, we have a number of undergraduate majors. Microbiology, the METOX department comes to mind. I think SVP has one where these like 4+1 programs, right? Where students essentially at your stage can, I don't know exactly you guys would know better than I would, but there are mechanisms by which, like say the MECA, the microbiology and environmental toxicology program, where if you're interested in a master's degree going into your senior year, you can actually get into that program, you can apply for and get into that program as an undergrad, and then sort of accelerate the time to the master's degree that way. So that's why I call this 4+1. And we have a relatively new graduate dean, Peter Beal, and he's a big fan of these 4+1 programs. And so in meetings with him, it seems apparent that these are going to become more popular on our campus, although chemistry doesn't have one. So that's another thing we need to be aware of. So yeah, so I think it's a personal decision. I think beyond that, yeah, I don't really know. I think it's the time and the career. Are there any questions about sort of master's compare and contrast with PhD study at this point, or thoughts that you might share? No?
I'll add something. I do know I used to be, some of you may know this, I used to be the advisor for CalTeach. And I know some students that I work with in my undergrads are now in chemistry are interested in becoming professors. And I believe that most of the time, and I just checked it on ACS, so I'm pretty sure this is right, that a master's is okay for teaching community college, whereas for a PhD is more so required for something like a university, like being at UCSC or something.
So that's true, and not to contradict you in any way, but in my experience, for even teaching at the two-year colleges, which are wonderful institutions in California that serve this amazing function, most of the people I know who are getting those positions have PhDs.
Okay.
And so that's at least my experience. So I don't know if that's really to the requirement, but I know that we've had a number of PhDs from our department go on and super stoked to land these highly competitive two-year college teaching positions. And so, so I think generally, if you're going to be a professor, be it a 2-year or a 4-year, the PhD is probably going to put you up the most competitive. But I don't know if that's strictly required.
Right. I mean, I confirmed it on ACS's website, so it could be very general and based on, yeah.
Yeah. So.
No, I'll say with respect to the stepping stone idea, I mean, I totally agree that it's a common path to do a master's as a stepping stone, but I'd also say that it's not really required. We, for sure, in our department, take students, a lot of them do have masters, but a lot of them do.
Yeah, for sure. I would say it's maybe like 15% of our incoming class will have a master's. So it's not like a huge majority or anything, but there's another chunk that's worth thinking about too that maybe didn't go straight from undergrad into grad school. So I would say the majority of students go straight from undergrad into grad school. The biggest slice of the pie are students like you who are already thinking about it and like preparing. Then there's sort of these other slices of people who go to masters, or people who work for a year or two. I did that, for example. I worked as a right? And then so I know, shut up. And that can be really valuable.
Okay, so let me just do a little bit of nuts and bolts about the process. Okay, so the way that the timeline would work, and I'm glad you're all juniors because then it just makes it straightforward, would be that you would be applying, most application deadlines would be in December of your senior year, December of next year, to start. So it would be December 22, January 23 to start fall of 23. So to start fall of 23, you would apply this coming December into early January, or when most of the applications are due. All the PhD programs would be due then. I know a lot of the masters, like a lot of the Cal State master's programs, those deadlines are a little bit later into the spring. There's for all the PhD programs, there is an interview process. And so you would get invited to an interview depending on when the application deadline is, usually 4 weeks or so after that. So ours go out right before the end of the year holiday. A lot of other ones go out into January. And then the interviews would take place in the late winter into early spring. And we'll talk more about that interview process in a little bit. And then you would get at some point after your interview, usually a few weeks after that, you would get a final decision on admission. And then generally, universities expect you to inform them whether you'll be attending that fall sometime mid-April, regardless of April 15th. I think that's pretty close to when most of them are. That sounds pretty right to you guys, right? Okay. So that's kind of the timeline, just so we're all aware. I thought it'd be worth saying a few things about what makes for a strong application and what you can be thinking about. One of the most important things is academic performance. So definitely admissions committees are going to be looking at your grades, and especially your grades in STEM classes. I will say it's not, because PhD programs, I'd say in general, are not as hyper competitive as medical schools. It's definitely not like we need straight A's like in medical school. So we definitely see a lot of students who struggle at first until they get traction and get motivated to study it and do research, and then we see a lot of improvement, and that's definitely something that's looked at. And so those are just things to think about, but overall, especially the most competitive programs, you do need pretty strong academic performance. The other important thing is research experience, because especially PhD programs and master's research programs are so intensive in terms of research. It's really important to go in with some kind of research experience. So it's shaped your interest, it's shaped your motivation, and basically you know what you're getting into by going into PhD dissertation research. And so it's not only skills that you develop, and really, and we could talk about this more, it's not about coming prepared with any specific laboratory skills in some area, but it's more just about the experience of having worked in a lab, what that takes, what it's like, and that, again, you kind of know what you're getting into when you're going to grind out 4 or 5 years in the lab doing your PhD research. The written statements are definitely looked at quite carefully. Generally, there's either one or two, but either way, there's kind of 2 components to them. One is what's typically referred to as the statement of purpose, which is what is your purpose, what are your interests, what is your motivation for going to graduate school, and what is your preparation. So interest could be referring to career interests, so long-term career interests, although as Michael was saying, not everybody knows what those are from the outset, and there could be lots of possibilities, but some kind of statement about what your potential career interests and long-term goals could be, but also what your scientific interests are. And it's definitely important to be able to articulate why you want to go to that program, why you're interested in that program, what area of chemistry, science you want to study, so that it's clear that that program is a good fit for you, and that's why you're applying to that program. And then the second part is preparation, and usually there, you want to have some very clear and exciting description of what research experience that you've had in the past. And definitely people reading these applications look for somebody to clearly communicate the research that they've done. And then the personal history part is just sort of more about who you are and what you're going to bring to the program, right? What you're going to bring to that department. Usually there, people will include things that kind of have motivate what their interests are. Okay, and then reference letters are always clearly important. I just bring that up because it's something you might want to start thinking about now and getting ready to ask letter writers. Usually this would be somebody, if you're doing research, your undergraduate research advisor is always an obvious choice. And then you and probably the most weighty letter. And then letters from other professors that you've had maybe in upper division classes, other sorts of mentors or advisors. Those are the types of letters that we see. And then important, but maybe less so, and also sort of to clear up some misconceptions. One thing that I wanted to say is that you don't have to be so concerned that you have majored in something or done research in an area that's exactly what you're applying for. It's a time from your senior year, junior, senior year of college up through the first year of graduate school. That's a time where people's scientific interests fluctuate pretty wildly. I'm an example of that. I was really interested in physical chemistry when I was a junior and senior. And by the time I got to graduate school, was much more interested in biochemistry. And that's a pretty big change. So if you're interested, let's say you've done synthetic organic chemistry research, but you're way more interested in biology, you could certainly apply to biochemistry programs. You could probably even apply to molecular biology programs. And the research experience that you had in a synthetic organic chemistry lab would still be regarded very highly. Because again, it's not so much about the specific techniques and skills that you did in the lab, but it's the beginning to think like a scientist, to think like a researcher. That's most important. So don't get too caught up in, oh, I can only apply to this program because that's what my background is. And I don't know, maybe some cases we had, like I remember like we've been marine biologists to chemistry and there's other crazy ones. Like
yeah, I mean, so I certainly agree with that. There are some exceptions just to be aware of. I would say, if you're, as an example, if you're applying to our chemistry PhD program, the coursework requirements of our chemistry PhD program are very, as you might expect, chemistry focused, right? And so if you're really sort of have a biology undergraduate degree, it's not as if you can't get in, but that is something to look at because if you have a PChem or something along those lines, you're going to need to do that in the chemistry grad program. So that's not quite as true going in sort of a different direction. So like if you were to apply to our umbrella program or these so-called umbrella programs that capture a lot of the different individual traditional siloed academic disciplines, right? And if you're applying to those programs, then the general requirements are more general. There's more sort of ways to customize it to your own interests and your own background. So that's just something to be aware of when you're looking at a program. If you're applying to a physics program, like you should have a strong background in physics, but if you're applying to say MCDB or Berkeley MCDB or something like umbrella or our own PBSU, then it can be much broader, right? And you can sort of navigate these kind of things. So that's why those umbrella programs have become so popular amongst a subset of students, because it does give sort of a room for lateral movement. And conversely, we have chemistry students who are just like super stoked on chemistry, and they're just, that's what they want, and they know it, and that's what they choose. So it's about finding a fit. So I agree, it doesn't have to be a perfect correspondence, but you also should be aware of what your requirements are and how that's going to challenge you.
And then the other thing that's definitely become less important is GRE exams. I think most programs probably by now don't require them anymore.
Yeah, we don't. Yeah,
we don't hear anymore.
Most are not looking at that. Yeah. I think everyone. So there's been some very good research demonstrating that outcomes do not correlate with GRE success.
So definitely look at the programs where you apply, and you might not even have to take it.
Can I just make a few quick comments on the other book?
Sure.
So the one quick comment, and this may or may not pertain to anyone in the room, but academic performance. So Seth did mention the idea of trajectory. Admissions committees definitely look at trajectory. So there's that. There's also life, right? So sometimes things happen and the academic, like the transcript is impacted for reasons beyond the control of the applicant, right? And those are also things that I can only speak for Santa Cruz applications, review. We, really analyze that. And the best thing that one can do, like you can tell your friends this, but it's something that really to be aware of is to like take that on. So that sort of that relates to what you will bring in personal history. So just to be clear, like if I'm looking at somebody's application and I see like there's a couple C's, something worse. I'm right away wondering, but everything else looks really strong. I'm sort of like, I wonder what occurred. Like usually there's something about that information. And then in some applications, you never find like something that addresses that, but in most, it might be stated. There might be some personal history there. And again, one doesn't have to divulge like, like personal matters, but just sort of like not being afraid to touch upon that and being like open to sort of sharing that personal journey. I think that can be very compelling, and in some ways even differentiate you as a strong applicant. So it's something
I get questions all the time about Should I just take any back in this class, or should I withdraw from it? If I'm applying to graduate school, how are W looked at on transcripts? As a piece to just stay on it, that's not right.
So I would say Fs are not great, if I'm being completely honest, right? Unless again, there's like a really clear a W, usually a student that's gonna sort of persevere and get to the grad school level has replaced that W somehow, right? Needed to sort of demonstrate academic excellence beyond that specific time. So the best case is to take it incomplete if that's like available. So that they can literally but yeah, I think to be at the top graduate programs, to be competitive, if you have Fs on your transcript, I think a W is probably better than choose. But in either case, if those exist, like shining a light on it in your personal statement and explaining that circumstance is really critical. It's just not the transcript. Question?
Talk about like looking at academic performance and like seeing like an increase in like the grades, but like would it also just like you also look at it as like just like overall like an increase in performance, like not just academics but like things that you've been involved in? Is that like the way that you look at applications as well?
I think so, and especially like the research part.
Yeah, because like, I don't know, I'm doing undergrad research right now, and like, I would say that my grades are just steady because now I have a different time commitment.
Yeah.
And, you know, studying.
Yeah.
So I would say, generally, the grades are really important. They're not the only thing, right? Research is also important, right? So there is sort of some magic mix, that like you're trying to strike down. In terms of time management as an undergraduate, I think one has to be cautious. I fell into this, but again, anecdotes are not that useful, but just to say, where is that some students are like really like there's like this magnetic attraction force for the laboratory. So, right? And somehow it's like more interested in studying for that exam. I would just like put out like a little bit of a warning that striking that balance is very important. So one should not be doing research at the expense of academic performance. That doesn't sound like that's what you're talking about. But in terms of so as long as you're holding strong, and building your experience base, that's great. But sometimes we have students who are just turning away from the classroom. That's not.
Yeah, like not like a decrease in academics for it.
So totally, yeah, and you're learning there because that's a key skill, right? It's that you're really getting into the kind of world there, different level in college or maybe it's that. They want you to throw research into it. It's not cool. So, sure.
Yeah. All right, let me quickly go through this. So don't want to give these guys fun talk. So in terms of the interview, so I mentioned after your initial application, it will be screened. The department will generally then offer you an interview to come to campus, assuming we're staying back in person. And at that point, you should be assured that there's the department's pretty confident in you. That to take it to the next level, it's not like we invite 10 times as many people to interview as we're going to admit. We generally only overshoot a little bit with how many interviews we accept. So if we want to like accept 40 people, we might make like 45 to 50 interview offers. And I think other programs are pretty similar. And part of that is because they pay for you to come. So they will pay for flights, lodging, meals, everything. It's kind of a sweet deal. You get pampered a little bit. It's because they're also trying to attract you to come to their program just as much as they're trying to interview you. So there's a structure. There's usually some information sessions that are kind of dry. The big part of it and where you're kind of being assessed are the one-to-one faculty interviews. So you generally will meet with 4 or 5 faculty in that program. Oftentimes you have input as to who you would like to meet with based on research interests. And those interviews are just like 20, 30-minute discussions with that faculty about your past experience, your interests, and that faculty's research program. And the kind of, as these guys could tell you, the shape of that and what happens during that varies widely from faculty to faculty, student to student, for sure. And then you'll have a lot of interactions with the current grad students, either oriented around science, like poster sessions and things like that, and also just social events like meals and things like that. And then the keys to doing this well, really the most important thing is to, just like you would communicate in your application and your statements, your research experience and your interests, to be able to do that with the people that you need, right? To convince them that you're motivated to go to graduate school. These are your scientific interests, and this is why that program would be a good fit for you. And then the other key to success is to just be engaged and ask questions and show that you're enthusiastic, motivated student interested in that program. Any quick questions about that?
One last comment that I forgot on that I want to say is that when writing your statements, another critical thing to consider and include is making the statement specific to the institution or the program that you're applying to. You'd be amazed, and that sort of like comes up with the each part in person as well. You'd be amazed at how you see applications where it's like this really generic statement. And those like are really hard to get over the hump, whereas when you're evaluating, whereas a student whose transcript may be a little bit borderline, has interesting research experience, but clearly really wants to come to Santa Cruz because this person, that person, really put their effort. That's really important in the statement. So I just want to remember the statement.
Like it would be kind of helpful to, in your statement, maybe point out a whole faculty that you would and or like specific research projects.
Absolutely. Yeah. So 100%. Yeah. So I think that often comes at the end of the statement or the beginning, right? Someplace where you know it's going to be captured, right? And you just have to remember that the people who are reading these things are reading hundreds of them, right? And so it's something that that you really want to pop, and I do a lot of these things. And my first pass is I scan and I look, is there something Santa Cruz specific in the statement? Find the way when it's there, when it's not, and then go back and read it proper. Still, now at that point, I've already a little bit of a bias that this person doesn't. And then even worse, sometimes you find like people are, I really want to go to Yale because. So,
the admissions committees really want to admit people they think are going to come.
Exactly.
That's really key because nobody wants to waste time.
Right.
So, right, like, so if we get an applicant, and their research interests don't really fit, then we're less enthusiastic. And then that's also advice looking where you should apply, which the slide was on, right, is that you want to be applying to places that are a good fit for your research. So the number one thing to look for when choosing a program, what programs to apply, is go on the web pages, look at the faculty, and make sure there's a handful at least of faculty. When you read it, you get excited and want to know more and potentially. So that's far and away yeah.
I just want to mention that at least for the programs that I apply to, that process can be really long because there's a lot of these places have a lot of faculty, especially if you're not exactly sure what you want to do. It's good to check out kind of related departments and reading through faculty's research. I mean, give yourself a while to do that. Definitely, I didn't think it would be as long.
Yeah. Cool. Yeah. Then, and these guys can talk more about culture and fit, but definitely different programs have different cultures. A lot of that's hard to get from the web pages, but definitely that's a big part of you going and interviewing. You definitely want to interview it at a few places to make sure that the culture is right and fit. And that could be, everything from how much is mentoring and graduate education emphasized to how well grad students interact with each other, interact with the faculty. We could talk, people are interested more about differences between, especially if anyone's interested in biochemistry, chemical biology, differences between departments that are in medical school versus College of Arts and Sciences, there's definitely like cultural differences there. And so just being aware